right, so welcome everybody. I appreciate you showing up for cybersecurity. So just a quick question so that I know where I'm at. So who of you is actively working with some sort of cybersecurity control framework or, oh, I see, okay, all right, great. Who has to answer questionnaires given to him or her in Excel format regarding controls and, okay, a couple. Okay, because that's what we're going to talk about today. Let me first quickly tell you about where I'm from. So I flew in here from Berlin, Germany. I'm working for a German company. We do have an office here in San Francisco, because we work for US clients as well. The two main products or projects that my company is known for is Samba. I don't know if you heard this one. It's like the Unix file, like the Windows file server for Unix machines. So that's like 6 out of 9 Samba core team members work for us. So the development is largely headed by SerNet. And the other tool that you probably won't have heard about is Very Nice. Who here has heard of this one? No one? Okay, so you just have to trust me on this. It's really well known in Germany, nowhere else. So it's like David Hasselhoff thing. I don't know. Okay. So, and that's actually what I've been doing. So I've been working in cybersecurity consulting and audits for a long time now. I've been, during which time I've been, I held the position as Chief Security Officer at an Airbus subsidiary for some time. I led the team of IT security professionals for the Deutsche Kreditbank, also in Germany. And so I'm more from the management side, the cybersecurity side, but I've always been coding the entire time. So I always ran into problems that I could solve by writing a piece of software, an application. I mean, my last name's Koderman, so that's, I have to code man, right? It's like, okay. Okay, so what I'm doing right now is I've moved sort of to the research and development side of things. We're developing the new version of the software that you didn't know about on the previous slide. I also have an open source software that concerns itself with vulnerability management. The links are all there. And I've been writing this suite of scripts called OSCAL, OSCAL for Neo4J, which is what I'm here to tell you about today. So if you're thinking about information security controls, I don't know, if you've ever been in contact with them, you're probably thinking about an Excel sheet or a PDF or a Word document, right? And I wanted to start with this because if we import these things into Neo4j, you'll get a completely different view of what a control could look like. So if you're looking at this, I don't know, I think it sort of looks nice, like a flower or a snowflake. Or the way in which you could also think of these is like they're sort of antibodies moving through your companies, like these antibodies are moving right through your body. And you want to keep them in place wherever something bad could enter your company or happen to you. So maybe keep this in mind. So these controls, where do you need them? I don't know if you've seen this diagram. It's from the Department of Defense. It was pretty well thought out, I think, which is why it gets referenced often. And it shows that when you start developing a new product, a new application, right, you would sort of start here, plan, develop, build, and basically through each step of your development lifecycle, there's something regarding security that you would have to keep in mind, right? So for instance, when you start planning, think about the threat model, right? So who here has done a threat model or worked with threat model? Oh, okay, a few, great. So the idea is don't just write user stories, also write bad user stories. You know, there's bad actors out there. You want to keep them in mind. And then, of course, there's stuff like static code analysis, dynamic code analysis, secure coding practices, right, that you want to keep in mind. And then when it goes to production, of course, you have to keep going. You have to make sure that you have a secure configuration, and so on and so on. So if you want to do this, right, if you want to protect your application, all of these standards and regulations and best practices, they actually can help you, right? They actually, because they tell you what you would need to do to achieve a secure configuration, for instance. And the thing is, there is a lot of them, a lot of these things. And all of them sort of go into the same direction, but they have different focus, right? As we all heard today in the keynote, Neo4J is now ISO 27001 certified, which is interesting because that's also something that I'm going to talk about. I'm kind of curious if they have used Neo4J in their own 27001 certification, because they could have, as I want to show in a few minutes. But the thing is, so there's lots of different frameworks, right? Lots of different guides, and you sort of have to make sense of all of them. And of course, they're all interrelated somehow. One thing that I wanted to depict here is there's this cybersecurity framework, which is interesting in the way that it doesn't actually have controls on its own. It just references controls from lots of other standards. It just tells you what you need to do, but it doesn't go into the details of how you should go about doing it. So we're going to continue, for the sake of this talk, with this one right here, the NIST standard 853, which has a nice level of granularity. So it's still sort of high-level management, but it's detailed enough that it actually tells you what you need to do, which is important if you actually want to do something. It has about 900 controls. If you roll it up with control enhancements, which are sort of sub-controls, you end up with, I think, 1,189 is the exact number of controls in there. So, yeah, that's a couple. And this standard is being published in certain formats, as an Excel sheet, as a Word document, and in the OSCAL format. So this is interesting. What's OSCAL, right? OSCAL is a machine-readable format specifically for control catalogs and everything that surrounds them, right? Everything that sort of accompanies them. And specifically with the idea of reducing paperwork, and improving the way in which we do these audits, right? In which we work with these management standards. Those are all, since they're published by NIST, they're either in the public domain or they publish them under an open source license, which is nice because you can basically, so if you want to integrate them in your own products or software or whatever, there won't be a legal problem with that, right? Okay, now if you want to take a look at OSCAL, this is what they have on their website, and here's a tip for you. If you need to draw an architecture of your system, make it look nice, not realistic, right? So this is the nice diagram of what OSCAL actually looks like. You see there's different layers, and these layers map nicely to the three parties that are involved usually. Because down here, the controls layer, that's the stuff that you get from your regulatory body, from your government agency, right? Those are the people who tell you what you should be doing. Then in the middle here, that's basically you most of the time. You have your component model comparable to your inventory of assets, right? The things you have and how the controls apply to them. And your system security plan. Whoever here had to write a system security plan? Okay. If you ever need to do that, there's a template that you can download. It's 258 pages. And this is why you'd probably rather do this with a Neo4j database and a REST API instead of sitting in front of a Word document with 260 pages. Okay, and in the top here, that was my job for a big part of the last years, the audits and assessments. So, right, this is the auditor who has to ensure that what you said in the implementation layer you were doing, you are actually doing. Okay, so again, this is the nice-looking architecture diagram. If you want to see what it really looks like, this is more like it. This is a class diagram that I made from the existing JSON schemas that OSCAL has. When you see this, okay, you will notice, okay, it's complicated. But I would see this as a positive, because when it's complicated, that usually means it's useful. Because it's not just some nice-looking colorful boxes. It's actually a grammar that describes all of the different objects that are taking part in your information security, compliance, risk assessment, and so on processes. Okay. I wouldn't be here if I hadn't imported this information into a Neo4J database. And as is often the case with Neo4j and the graph database, once you have the information inside the graph, you get a different view. And with a different view, you gain new insights. So when I did this, you notice the date down here somewhere. It was almost exactly 1 year ago when I started experimenting with this. I noticed a couple of hiccups, like for instance, there were these loops at the controls where the control was referencing itself. And I thought that makes no sense. And I asked them and I pointed out, and it actually turned out to be a mistake in not only the OSCAL data, but the underlying FISMA data source. So FISMA is the Federal Information Security Management Act, which is the team or the regulatory body behind this content. So they actually had to move this upstream to get it corrected. So I thought, okay, I had the feeling I'm onto something, right? Because if no one had noticed these mistakes in the JSON or the XML files, it could really mean that by getting this data into the graph, you could gain new insights. So I continued, and just to compare this snowflake of a control that you saw in the beginning, this is probably what, if you've ever worked with controls, this is what you were thinking about, like a huge PDF document. And you can see these different parts of the PDF over here in the graph as well. Like you have the controls with the control enhancements, those are the blue nodes. The actual control statements, which are further down, those are the amber ones here, or the brown ones. And the parameters, those are the red ones. So for instance, down here we have a control statement saying that you need to disable temporary and emergency accounts after X amount of time. And the amount of time, that's up to you to decide. So the interesting thing here, if you look at this, and you're going through this, and you're filling out all of these parameters, which part of this graph do you have to share with your auditor to enable him to assess your organization? It's just the red ones, right? So because he has all of the other information, he doesn't need it. All he needs is you telling him how you implemented or how you decided to implement certain parameters of these controls. So this is nice about OSCAL. It really facilitates information sharing between the different parties that are involved in this compliance procedure. And it doesn't stop there. So we can take a look at what we can do with this data inside of Neo4j. So for instance, the auditor can take your parameters, and with this query, for instance, he can determine what he needs to do to verify that you actually are doing what you told him you are doing. And you can see that there are different assessment methods that he is supposed to use, like for instance, test something, examine something, or interview someone about this particular topic. Okay, this is just the same information as the graph. We can continue. So let's say I'm the auditor. I want to verify. I have read, okay, I need to interview you about this topic. Then I can find out who I need to interview. So I can tell you, okay, please make me a date with system network administrators, organization personnel with information security responsible, and so on, for these topics that I need to interview them about. But it doesn't stop there. And the next thing is something that I get really excited about, and you probably won't because you've never been in this situation. But you have to imagine that what happens most of the time is you're sitting in front of someone, right, who has taken time off his usual work regimen to talk to you, and you ask him the questions that you have, and then he asks you, okay, is there anything else I could tell you about, right? Is there anything else you want to know from me? And in this case, you would have to know, okay, what other topics could this particular person be able to tell me about? And this is something that you can now finally get out of your database with just basically the query going the other way. So you're saying, okay, I have a certain person sitting in front of me with a certain role, and what are the topics, the control statements that I could now ask him about. Okay, so this is all still describing manual activities, right? Like the interview that's being conducted and so on. But we're improving on that. On May the 19th, actually, it was the first time that a cloud provider has successfully entered a FedRAMP authorization profile in this OSCAL format. So it was the first time that they didn't have to fill out the 260-page Word template. They could instead just generate the data and send them a JSON file or XML. I'm not sure what they actually used. But this is really helpful, and it's especially interesting because these FedRAMP profiles or baselines, right, they exist for different protection levels. So it depends on the kind of information that you want to put into the cloud. And then the FedRAMP program tells you, especially if you're a government agency, what are the controls that your cloud provider needs to prove to you, has to keep in place, so that you can entrust him with your data. And these FedRAMP profiles, I imported them as well, and they constrain some of the parameters that you were previously able to just determine by yourself. So for instance, this is again the same control that we just had. So it says, okay, you need to remove temporary accounts after some time period. And while previously you could just determine this by yourself, you're not constrained to either no more than 30 days or 24 hours from last use, depending on how your protection requirements actually are. Okay, so again, with one query, you can now find out, or you actually don't have to fill in most of these parameters, but you can just take them from the FedRAMP profile and say, okay, guys, you have to do this every 24 hours, or at least every 24 hours. It's not our choice anymore. Okay, of course, you can do some basic analysis of the controls that you have in there. For instance, it just lists over 2 hops the controls that are dependent on other controls. And you can see here that there are certain topics like security and privacy engineering principles, which just after 2 hops get referenced more than 1,000 times. So these are probably central, important topics. And at the low end of this list, you will find some controls such as water damage protection, which is referenced only once. So it doesn't mean it's not important. It just means that it has a narrow focus, right? It's a specific topic. If you've taken care of your water damage protection once, you're probably done. You won't have to think about it ever again. Whereas secure engineering principles are something that crops up in most other topics at some point. Okay, you could figure out how much work you will have to add when you move from a moderate to a high baseline. Like if you want to determine, okay, is our information, is it highly sensitive or just moderately so? And this would mean the additional work that comes with it. You could do queries such as this. And this is the point where it really gets interesting, because, and it also takes us back to the beginning of the talk when we were looking at these different standards. Because OSCAL or the OSCAL example content that they provide already contains some links to back matter. So what we're looking at here is access control. And down here, actually, we are looking at the controls for the access control policy and user identification and authentication, right? So on this side, we have identification and authentication, and here is the identifier management. And these additional standards and best practices that you will see linked here, those are very, well, they are lower level, right? They're more technical, more detailed standards for certain topics. So for instance, this is personal identity verification for federal employees, or PIV. These are biometric procedures for PIV. This is the interface for PIV. You have other topics here. FIPS 202 is actually the SHA-3 hash standard, which you might know. You have standards for test procedures and applications that are derived from smart card systems, standards on cryptographic modules, on these are cryptographic procedures and key sizes, and so on and so on. So pretty dry stuff, but it helps you if you have to keep track of it for regulatory purposes. But it doesn't help you that much in your daily workings. So we have to add to that. And unfortunately, OSCAL is not quite there yet, but we can add other sources. So for instance, there's one project, it's called the Security Control Knowledge Graph. I put the link to the GitLab right here. If you're interested in the slides, by the way, you can contact me. You don't have to copy the links of the screen. And this is interesting. It doesn't go into that much detail as the OSCAL import, but it has more standards. And it allows us to formulate a query. For instance, let's find me a connection between these NIST controls and COVID-5. Because let's say that you're being audited and your auditor doesn't care about NIST. He cares about COVID. And then the next day, another auditor comes and he cares about ISO 27001, right? You don't want to do the same work again and again and again and again. You want to pick one working standard, let's say 853, and then just give each auditor the view that he needs to be happy. So we can run a shortest path in Neo4J. And in this case, I didn't constrain it much. I just told it, OK, just find me any path between COVID and 853, and it did. And the interesting thing is that you can see here's the COVID control, here's the NIST control, and there's something in between. And this intermediary that was identified, this node, is a node coming from the NIST cybersecurity framework. And that was the one that I had on my first page where I said this is a standard that doesn't actually have its own controls. It just references controls from other standards, which makes it really useful to do these compliance mappings that we can see right here. And this is actually really useful if you have to make auditors from different regulatory bodies happy, right? Okay, one thing that I personally find very exciting is this data model. It's actually it's a Neo4j database, so you can just import this one right away into your database. It also includes the DISA sticks, and those are from the Defense Information Security Agency. These are the security technical implementation guidelines, and those are very down to the hardware, down to the software, system hardening guides. So they are very specific. Some of you probably worked with them before. So for instance, in one of these sticks that are published by Red Hat, for example, you will find measures or controls such as SSHD, disable empty passwords. So this means, okay, no empty password on our secure shell systems. And what's interesting about this is finally we can close the gap between the management control level and the actual operations information security level, right? Because there were always people that were in IT security, and they had to make sure that, of course, empty passwords are disabled. But now we're able to tell them, yeah, okay, it's good that you're doing this, because if you wouldn't, we would have problems with ISO 27001, and there's a whole bunch of controls that actually depend on not allowing empty password on certain systems. COVID 5 does the same, and here's also some industrial automation standards which also say the same thing. So this is the query that gives you this graph, and as you can see here, it references the actual, the name of the script is still in the name of the node. So these are actually the individual hardening steps that this script usually ensures, but now you can use them inside of Neo4J. So OSCAL is not quite there yet. They're talking about it, about this level of control mapping, but if you look at the GitHub issue, the GitHub discussion, you will find some screenshots that will look familiar to most of you. So even they are looking into Neo4j to solve some of these questions that they're having. Okay, I'm going to switch over now. I'm not sure if this will interest all of you. I hope it will. So what I've shown you until now was the result, basically. Yeah, and now I will just quickly show you how I imported these JSON files and highlight some of the problems that I ran into while importing these JSON files, because it's not as straightforward as you might think. So when you first start out, it seems simple enough. You have a JSON file, it's cool, with APOC, you can just load it directly from the GitHub URL of the official US NIST repository, so that's fine. And then, you know, JSON, right? It's just this hierarchical structure. So you just start iterating down, like unwind, unwind, for each, right? Just adding content. First of all, you have to create an index. Ideally, create the index before you even start importing any data. In my case, it was enough to import it after the first run, but it will speed up the following operations by one order of magnitude, so tenfold, basically. So, okay, that was still easy enough, but the next problem that I ran into, and that you might also run into, the data that I imported seemed innocent enough. So one of these files, the one that you're seeing here, was, I think it was about 1.2 megabytes, and the file had about 40,000 rows, right? 40,000. That's a lot if you have to work with it manually, but that's not a whole lot of nodes for Neo4j. But when you just naively recurse down into your JSON structure at about level 4 or 5 of doing that, as you can see here, in my case, these 40,000 rows turned into 412 billion rows. And that was for the case of the properties. And on a parallel track here, you could see that for the control subparts, those were still 149 billion rows. And in practical terms, this means that 1.2 megabytes of data turns into well over 2 gigabytes of data. And you have to solve this somehow. So I chose one way, which was, I'm afraid the colors don't come across really good here. I chose one way. I just split up my import into 2 halves. And first I ran through the entire file once, and I imported the upper levels, so to speak, of the JSON. And while doing that, I created some compound IDs. And these compound IDs then allowed me to reference the nodes that I had created during the first run, during the second run, in which I imported, let's call it the lower half of the JSON hierarchy, right? So this works. It's one way to do it. Another way to do it would have been just to increase the heap size, but that will only get you so far. I mean, you will be able to exceed any heap size if you don't know what you're doing, right? And there's also this feature which it works like you say call, and then you give it the actual import, and they say in transactions of 20 rows, and then it will dump the data in those 20 rows. I was not able to do this at the time because I did not know about it. Okay. Okay. Pardon? I had 2 gigabytes. So, and I kept it at 2 gigabytes, this worked. By the way, this import won't work on the free tier of Aura, which where it's not the total heap size that's a problem, it's the transaction max size, which is 250 megabytes or so. And I mean, if you improve, we could improve this query a little bit to work with the 250 megabytes, I'm sure. In my case, I was using the community edition, so at this point, it was good enough. So I just kept it at that and kept going. All right, so what we were dealing with here is the relations, right? And as you've heard multiple times in many talks here, I'm sure, in Neo4j, relations are first-class citizens. In JSON, you have actually 2 kinds of relations. First, referenced ID values, right? But the tree structure of the document itself. That's what I had to deal with here, where it usually gets you in trouble. Dealing with the ID values, most of the time is pretty straightforward. You can do something like a regular expression match, right, where you get the ID from the JSON and then just create the node to it. Or you could also do string operations like here. They had little like URIs in it, and we had to split those on the anchor to get the actual ID that I needed to use. But this usually works, right, in some way like this. Okay, we're getting to the end of this talk. And so far, we have only talked about this part down here, the profile model and the catalog model, because that's what you can get finished and ready from your regulatory body. The 2 layers right here, that's actually you. So that's information that no one gives to you. You can't import it from somewhere. You have to have it. You have to enter it. So what I'm doing in my project here is we're generating code to get a REST API so that you're able to either enter it by hand or import it from some other existing data source that you might have, such as your inventory of asset database, basically for a component definition. So just quickly, what I did was I used Spring Data Neo4j, which is quite nice to get a REST API written in Java for Neo4j quickly. I generated the classes, the stub classes, using Swagger CodeGen from an existing Open API REST specification you can actually find on the NIST homepage. And then you have to clean up the generated code somewhat. For instance, one thing it does, it generates these nice string literals that are larger than string literals are allowed to be in Java, only to tell you at the end, you see all this, that's not implemented. Right. So that's not really that useful and it doesn't work. Another thing was OSCAL actually had a bug in their regular expression for the date time. And as I'm sure you'll immediately notice, there's missing a closing bracket right here. So, okay. You only run into it if you decide to use it for something. Right, so I had to tell them about it. I don't think they like me anymore because I keep mentioning mistakes, and that's a shame because I think they're doing really great work, and it's desperately needed because no one wants to work with these controls in Word and Excel files anymore. Certainly not me. So this is what I hope we'll be getting it soon. We have REST APIs, and we can just exchange most of this information between systems without manual interaction automatically. So we have time for more interesting stuff. Okay, that's it from me. If you want to take a look at it, those are the links to the GitHub repositories where you can find the import scripts and the REST API as far as it's implemented. And if you have any questions, feel free to ask them right now.